So, lesson number 4. And look, I got a new shirt just for you. I bet you thought I only had white shirts, huh? Okay, so maybe I have another couple of shirts, but something new. And today we're going to talk about exponents and roots. And exponents are exponents and roots are not where you came from. No, we're looking at numbers. So let's define what we're talking about. So, let's say, for example, we have something that looked like this. A to the B. This thing we call the base. And this thing we call the exponent. And the whole thing we call a power. Okay? Good. So, as an example, five to exponent 6. What would that be? As you suspect, we write 5 6 times. Yes? 1, 2, 3, 4, 5, 6. And they all have multiplication between them. Yeah, right? So 5 times 5 times 5 times 5 times 5 times 5. That's 5 to the power 6. Rules of exponents, very important to remember. I'll give you the rules, and we will see how they are valid. All right? So the first one would be x to the power 1 is equal to x. All right? Now, x, of course, can stand for any number or any letter. What do you mean by the power 1? So what does this really mean? Let's pick a number. You pick a number. No, I'm going to pick a number. Good. So we would say the 7 to the 1 is equal to 7. And of course, this says that any number to 1 is that number. Why should this be true? Let's see how we can derive. Well, we can actually use this, derive this and bring in some other rules as well. If we know, for example, 7 to the 3 is 7 times 7 times 7. Very nice. Now let's say we did it this way. All right? Say we had 7 to the power 3 divided by 7 to the power 2. Now you may remember the rules of exponents for this, but how would we do it, as we say, if we expanded this? What would it be? 7 times 7 times 7 divided by 7 times 7. It's a fraction. We can cancel. All right? So 7 cancels 7, 7 cancels 7. Anything divided by itself is always equal to 1, not 0. So this really reduces to 7 times 1 times 1, 7, over 1 times 1, which is still 1. So this is equal to 7. I'll give you another example, and you can see how we can derive a general idea. Let's try 6 to the power 4 over, now let's take something bigger. How about 6 to the 5 over 6 to the 3? Okay? 1, 2, 3, 4, 5, multiply, 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 over 1, 2, 3, multiply, multiply. Again, playing the same game. 6 and the 6, 6 and the 6, 6, 6, 6, 6. What do we get? 6 times 6. How can we express that as an exponent? 6 to the power 2. So what now can we use for a shorthand form? We will derive another one of the exponent laws as well. What's the shorthand form? when you're dividing exponents like this, now notice, the rules apply when you have the same base. It's very important. The rules of exponents apply when you have the same base. That is the same big number. Not the little number, not the exponent, but the base. So if it's the same base, what do you see here? 5 take away 3 is 2. 3 take away 2 is 7 to the what? 7 to the 1. Okay? That's why this is true. Anything to the power 1 is that number, and we can derive it by simply looking at the actual arithmetic. All right? So what did we just derive here? That if you have x to the a over x to the b, the answer is going to be x to the a minus b. All right? Very important you remember the order in which this is done. And this will expand into other areas where we'll see other representations where maybe before they didn't make much sense to you. But now we can actually show exactly what is going on. All right? So this means that if we had, for example, x to the 3 over x to the 2, that would be x to the 1. And as I showed you before, that's the same as x. Anything to the power 1 is that thing, is that number. All right? Now, let's look at another example which we can prove. And that is x to the 0 is equal to 1. But using the examples we just had, that becomes very simple and easy to understand. All right? Now I need more space here, so I'll just put that down in here. Then I'll have to get rid of this. Make sure you write it down. How do we get this? Let's say, again, we went to 7 to the 3. Only this time we're going to divide it by 7 to the 3. Now, we know, we've seen already many times, anything divided by itself is equal to 1. But what if we did this by way of an expansion? All right? 7, 7, 7, times, same thing on the bottom. Okay, now, they're going to cancel. Cancel, 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 cancel. It's 1 over 1. We knew that. We knew it was going to be equal to 1. Didn't have to do that. Anything divided by itself is always 1. But what does this tell you? What's the shorthand form? If the bases are the same, it's going to be a minus b. 3 minus 3 is 0. 7 to the 0 is equal to 1. And we can show that any number to the power 0 is always equal to 1. Pretty cool, huh? Now, in the same way, what if we had x to the a times x to the b? What would that be? This you probably do remember. When the bases are the same, we add the exponents. Very easy to prove. Let's say we had 5 to the power 2 and, times, it only works for multiplication and division, times 5 to the power 3. So if we expand this, what do we have? 5 to the power 2, that's 5 times 5. 5 to the power 3, again, this is the multiplication sign in here, okay? 5 to the power 3, 5 times 5 times 5. How many times do we see them? 1, 2, 3, 4, 5. It's 5. What's that equal to? 5 to the 5. And I can do this with any letter. If this was x squared and x cubed, we'd have xx, xxx, that's x to the 5.